in the last class, we could ultimately arrive to the Howard projection of the glucose. And we have found that now we know how to draw alpha D plus glucose and beta D plus glucose. And I also told you that alpha D plus glucose and beta D plus glucose, they are not enantiomers, but they are anomers. Why? What are anomers? When the configuration of two structures differs only at the configuration at a certain specific carbon, that is called anomers. And that carbon around which the structure differs is known as anomeric carbon. So in case of glucose, we have found the anomeric carbon is C1. Okay. So again, let me draw it. So I told you it is very easy to draw. First, you have to draw one pyrene structure. Then next carbon will be CH2OH. Then after that, we draw like this. Then you will put hydroxyl group in opposite positions. So it is in the top. So this will be in the bottom. This will be at the top, and this will be at the bottom. Okay. Now we fill up with hydrogen. Now, by convention, anything whenever you say alpha, that is below the ring. So here, this is below that. Okay. So this is the alpha D plus glucose. Or what you can call it, alpha D plus glucopyranose. Why? Because this is the pyranose. Similarly, CH2OH, H, OH, H, H, OH. And this is, the top is beta. So this is, beta D plus glucose, or beta D plus glucopyranose. Okay, what are they? They are anomers, not enantiomers. Why they are anomers? Because the structure of these two structure differs at the configuration at a certain specific carbon. What are these carbon here? This is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. Now, why it is 1? Because this was the, see, glucose has 6 carbon, and in 6 carbon, for you have aldehyde carbon, and below you have CH2OH. We have learned in nomenclature that if there are 2 functional groups are there, one of them is given higher priority. So in between glucose and alcohols, aldehyde gets the higher priority. So this is the carbon of aldehyde. It's not that of our own we have started numbering, no. Okay. So here, these are the anomers. And which is the anomeric carbon here? Anomeric carbon is C1. Okay. What is the specific rotation? Alpha D. Sorry. The specific rotation is alpha D. It is 110 degree. Okay, 110 degree. This is plus. And this is alpha D is plus 19.7 degree. Now, what is this? Alpha is the specific rotation. What is D? D is the wavelength of the light, which turns the which is being passed to the solution. We use a sodium lamp. From sodium lamp, whatever the wavelength that comes out, that wavelength is given arbitrarily given a name called D line of sodium. So this is alpha D. All right. Now we have found that if you keep the glucose solutions for some time in water, in that case you get an equilibrium. When they attain equilibrium, they shows a rotation of 52.5 degree, and that stage is called muta rotation. That is, alpha gradually goes to beta and beta goes to alpha. So an equilibrium mixture is attained. In that equilibrium mixture, the rotation of the solution is 52.5, and that phenomenon is known as muta rotation. Remember. So you have come across two terms which you did not hear earlier. Last class only I told you. You have heard in haloalkenes, you heard about the enantiomers, diastereomers. And after that, when we come to carbohydrate, we have come across another term called anomers. And these anomers are interconvertible. Enantiomers are not interconvertible. Whichever way they will form, they are rigid. They will not change their structures. But the anomers, they changes their structure. One attains the other, and other one again comes to the previous one. Clear? And that process in which these structures are interconverted and ultimately reaches an equilibrium, that is called muta rotation. Muta rotation means what? Where from the word muta rotation has come? It has come from the word mutual rotation. Okay. Now we'll go for fructose. All right. Fructose is a keto hexose. Okay. It is obtained by the from the hydrolysis of sucrose or cane sugar. All right. It is 1.5, 1.7. I'm a little wrong. It may be wrong also. 1.7 times sweeter than sucrose. Glucose sweetness is much less. Okay. Now, what is the structure? See here. CH2OH. C. Then rest of these structures are same as glucose. 1, 2, 3, 4, 5. Yes. Now in glucose we know 3 of the weights on the right hand side. So this is 1, 2, this is so right. This is like this. Then rest is, next one is on the left hand side. Okay, see, this one. Where from we start numbering? It has alcohol group and ketone. Ketone gets a preference over alcohol. So I have to start number from here. 1, 2, 3, 4, 5, 6. Now, how many symmetric carbon it has? It has 3 asymmetric carbon. Glucose has 4 asymmetric carbon and it shows 16 optical isomers. Out of the 16 optical isomers, we have 8 structures. 8 structures with their mirror images. Okay, so it has 3 asymmetric carbon atoms. So it can show you 2 to the power 3, that is 8 isomers. Out of the 8, 4 will be the molecule and 4 will be their mirror images. Okay, now it also shows cyclic structure. In case of glucose, we have found that this oxygen reacts with the aldehyde. So what was the structure now? See here, 1, 2, 3, 4, 5, 6. See, this is the one. See, but in case of the fructose, you have the carbonyl carbon, second carbon. So the number of the what will be the size of that ring structures? 1, 2, 3, 4, 5. So fructose will show you 5-membered ring structures. So that I'm going to draw. Okay, before that I like to tell you. See here, because I have to find this configuration. Configuration or not configuration, relative configuration. A relative configuration you have to compare with the glyceraldehyde. We have 2 types of glyceraldehyde. Capital D, D plus glyceraldehyde and capital L minus glyceraldehyde. In D-glyceraldehyde, OH is on the right hand side. See here, is it not OH in the right hand side? See, what is the, how does the glyceraldehyde look like? Don't forget. These are not difficult, only you have to be little bit aware. See here. Is it not the same unit we have it here? So if you have this same unit, then what should be the name? See here, D plus glyceraldehyde. D plus glyceraldehyde. Is it not? So here the name is D. Okay, now very interesting. In this case, you will find fructose rotates the light towards left. So I have to put a negative sign. In glucose, they rotate the light towards right. Fructose rotates it towards the left. So it will have a negative sign. Okay, so minus fructose. So I told you that capital D and capital L has nothing to do with the rotation of light. Capital D and capital L is assigned only for the structure of the molecule. Okay, so it is having an optical rotation. I think this optical rotation is very large. It is alpha D equal to minus 92.4 degree. Minus 92.4 degree. I'll again discuss when I'll go to sucrose. So what will be its cyclic structure? Its cyclic structure is it is a 5-membered ring. Okay. See. So this is one. In this case, we'll start from here. So what we already know, this H2 on the top, H2OH, and they will be in alternate position. So on top, the bottom and should be at the okay. Now when this goes and attacks, I told you if it attacks from the above, then this will go down, and if it from below, then this will go up. So in this case, when the wedge group is below the ring, what do we call it? Alpha. So this is the alpha D minus fructose. Okay. Another will be CH2H OH OH and OH. So this is beta. So this is beta D minus okay. Now, that's because we call this is a pyranose structure. This 5-membered ring is not called pyran. 5-membered ring is called, see, one molecule is there in organic chemistry. See, when this was like this, we called it pyran. Okay. This is called pyran. Now, there is another molecule which is 5-member. Okay. This is called furan. So this is called the furanose structure. So in that case, is another name will be alpha D minus fructose. Furanose. And similarly, this will be beta D minus fructose. Sorry, one word, one word. Furanose. Please write the structure. So we'll remove this one. Now, see here, I'll put the number now. So this is 6. Sorry, it's not this 6. This is 1. This is the carbon of P2. 1, 2, 3, 4, 5, 6. So 1, 2, 5, 6. Okay. Look, they are anomers. These are anomers. Now, what is the anomeric carbon here? Where does it differ? In glucose, it's differed at C1, anomeric carbon. Please remember, in case of anomeric carbon is C. In case of glucose, it is C1. Draw. Okay. Now we'll go to disaccharide. I said, do you have any question on monosaccharides? I told you. Any question on monosaccharide, or you have already learned? Huh? What happened? Yeah, this one does not go. So no question. শুরু করতে হবে মনে হয়, আমি তো কত বাজারে সাজারে যাই না, নিয়ে এই না সেই না, ভয়ও লাগে। কিসের ভয় লাগে? কলে দিয়ে বসাবে, বসবে যেটা তুমি বসবে। না এমনি আসে না, পাকে আছে সবসময় দেখে দেখে আসতে লাগে। না কালকে তো মা ছিল না, তাহলে এই জন্য আসে সবসময় কিছু না কিছু। আমরা মারবো না। So what is the definition of disaccharides? The case the carbohydrate on hydrolysis give 2 units of same or different monosaccharides are termed as disaccharides. समझा? They're called disaccharides. Okay. So now, example क्या होगा? Sucrose, etc. Okay, let us go for first one. Sucrose. Formula is C12H22O11 plus H2O. So if I hydrolyze this one, I will get here C6H12O6 and C6H12O6. This is glucose and this is fructose. So what does it say? It gives us 2 units of same or different. So they are different. Okay? So this is this. Second one is maltose. The formula is same. So it is C12H22O11 plus H2O. It is going to give you 2 units of glucose. Okay? This is glucose. Third, lactose. I told you, lactose is called milk sugar. So C12, H22, O11, H2O. It gives you C6, H12O6. This is called galactose. Okay, and this is called glucose. See, all the carbohydrates, most of the carbohydrates name end with OSE. By convention, this is being given OSE. Okay, and most of the enzyme name ends with ASE. So this is the example. लिखो जल्दी. And moment you finish, you tell.
Done, sir.
Done. Very good boy. Okay. So now we'll go for the first example. Sucrose. This is the most abundant disaccharide in the world, in the nature. Sucrose. Apupang. अच्छा. रुको. Let me bring book. It is the most abundant disaccharides in nature. It is freely available in most of the fruits and also in some tubers. The highest concentration of it is found in sugar cane and sugar beet. So from there only we get the sucrose. So you know how to get sugar from sugar cane? No problem. You start growing sugar cane in your house. All right. Then when they become mature, the sugar canes have been taken and they are being crushed into juice. And this juice is filtered. After filtration, the sugar cane juice is being boiled and added some substances to precipitate the colloidal impurities present in it. Okay, and after that, the sugarcane is concentrated, and from the concentrated solution of sugarcane, you get the crystals of sugar. But this sugar is little brown in color. All right, when it is brown in color, then this is being again dissolved in water and treated with activated charcoal. Okay, so activated charcoal absorb the colored impurities. From there you get clear solution, and from that one you crystallize, you get the colored sugar crystals. Okay, but if you, instead of crystallization, if you concentrate this, then in that case you get, or in India we also call it guru. All right, so this is the story of sucrose. Now, sucrose is made of 1 unit of glucose and 1 unit of fructose, where the monosaccharide units are joined with each other through an ether linkage known as glycosidic, known as glycosidic linkage. Okay, see, these lines are important because you will be asked to write the definition of glycosidic linkage. If the question comes, what is glycosidic linkage? Then you write the monosaccharide, where you remove where the monosaccharide units are joined with each other through an ether linkage. Okay, I'll write down again. Glycosidic linkage. Glycosidic the monosaccharide units are linked with each other to an ether linkage. To form higher
जो উঠেছে তাহলে আছে কিন্তু নন ভেজ
higher
নন ভেজ না
to higher carbohydrates. Wait, this definition I think okay. Annulate and such linkages are known as you don't write this one, huh? Known as glycosidic link. Did you write this portion? Hello.
Yes, sir.
Oh, yes, sir.
Yes, sir.
Then don't write this. Don't write now. Have you already started writing?
Yes, sir. Completed.
Done, sir.
Done, sir.
Okay, finish. Then this one you put it in a square bracket. This is very important and put one star. Acha, finish now, na? This portion?
Yes, sir.
Acha, very good, very good. Now I'll drop this portion. Right. Then you write here. This is continuation. Put a bracket now, so I'm going for continuation. You write in glucose. Sorry. In fructose. In sucrose. C1 of alpha D plus glucose unit is joined to the C2 of beta D minus fructose through a glycosidic the structure which is given in your book, don't read this one because it is difficult for you to understand. They should know that what type of structure student can understand. Useless people. Okay. Let it up.
Done, sir.
Okay, now see. So I throw it. See here. beta D minus. Moments beta means this OH. And this is CH2 OH. So this is beta D minus fructose. This is 1, 2, 3, 4, 5, 6. Then it links with what? C1 of glucose. So I have to write the glucose structure now ulta. No problem. CH2OH. Now all confirm. See alpha. So it is H. Okay? And write it like this. Don't write. First try to understand. See, in our alcohol chapter, we have found that when you take two molecules of alcohol, and if you have taken concentrated H2SO4, okay, then what is the temperature? Huh? Sauspa light, 413 Kelvin. What happens? See, a molecule of water goes out, and you get here ether. All right, but here sulfuric acid is not added in sugarcane field. It is being condensed by enzyme. See what is going to happen now. So in that case, you'll find this molecule of water, and this oxygen will link with this. So what will be the structure now? See, I'll draw it like this. Okay, now I'll draw it like this. I'll draw it like this. Okay. Then I'll draw it like this. This is CH2OH. So this line first I have written. Why did I write the line? Then it is easy for me to draw that. I know you know my handwriting and structures are very bad. You can draw much better than me. Okay, so this is this. This. Then I write this one. CH2OH. Then this Hajrang, Sapo. Then again Hajrang. Then Sapo. Okay, so this is the structure of sucrose. In your book, they have written like this. They made a linear structure. In that case, what is done? They have just twisted their molecule and brought it in the same plane. No, don't do. You are not that expert to remember all this structure. You know this structure, exactly like this. So this is sucrose. Okay, this is optically active. So let me see its optical activity. Hmm. 6.5 is a dextrose.
Done, sir.
Okay. Can I rub it?
Yes, sir.
Yes, sir.
Okay. I'm going to. I will not run this question. So it is a colorless, odorless, crystalline, solid, soluble in water. It is sweet in taste. It is sparingly soluble in alcohol, insoluble in ether. কি সে?
কালকে ওই তো- আমি শুনেছি কালকে যখন ও যায় স্নুপি ইয়েতে বসে
Rotatory. Alpha D plus 66.5 and does not undergo muta-rotation. It is a non-reducing carbohydrate. See here, that day I told you what is why when it should be a reducing carbohydrate. When it is having a hemiacetal group. See here. Do you have any H here? No. This is linked to carbon, oxygen, and carbon. I told you what is how does the hemiacetal looks like? Hemiacetal looks like see this. See here. This is carbon. This is carbon. Sorry, this is carbon. But you hemiacetal means what? It will come out and you will get here R C H. It will come out. And you will get here now R O H. This is called hemiacetal. And then you get free radical. But suppose if you have taken this and this is linked with R, this is linked with R, say it's R1, R1, R1. In this case, hydrogen is missing. So this molecule will not break to give you aldehyde. Understood? So this is hemiacetal. Okay, and this is acetal. So this will never, don't write. This will never give you aldehyde. So because we know aldehyde is going to reduce tolerance reagent, but it does not form. See here. Here you have a carbon. This oxygen is bonded to another carbon. This oxygen is not bonded to hydrogen. So in that case, this molecule is non-reducing. So I'll write down. Why it is like this? It is a non-reducing carbohydrate due to the absence of any acetyl group and does not produce aldehyde in produce any free aldehyde group in aqueous solution.
জানি না আছে কি না, তবুও এটা ঢোকায় দিলে একটু কন্টাক্ট করে খেলে দিয়ে আসে।
Others also have done.
একটু করে খুলে দিয়ে এসো।
Yes, sir. Yes, sir.
Oh. Now we are going to study a very interesting thing of sucrose. Now we write here inversion of cane sugar. Right here. Sucrose is dextro rotated. On hydrolysis, it gives an equimolar mixture of glucose alpha D plus 52.5 degree and fructose alpha D minus How much? 92 point, I think something. Let me check. Huh? 92.4. Okay, now let me correct it. Sorry, dear. 52.7 and minus 92.4 degree. See here. In this case, C 12 H22 O11. Sucrose. Alpha D is plus 66.5 H2O. C6 H12 O6. Glucose. Alpha D plus 52.7 degree. C6 H12 O6. Fructose. Alpha D is minus 92.4 degree. See what is going to happen? Initially 66.5 degree. It has given this and this. If you add, the value will be positive or negative.
Negative.
Yes. So what happens now? On hydrolysis, the optical rotation changes. So we'll write down here. After complete hydrolysis of cane sugar, that is sucrose. The optical rotation of the solution changes from dextro rotatory to levo rotatory. Yes, the levo rotation of fructose is more than dextro rotation of glucose. Such phenomenon Such phenomenon is known as inversion of sugar and the mixture in the solution is called invert. Say at home you have made lemon tea. You'll find lemon tea is sweeter than the normal tea. You may laugh because you have already poured there citric acid. Why you know? Because you know that fructose is sweeter than glucose. So when you make lemon tea, you don't have to pour more because in hot water, when you have put lemon tea, the process of hydrolysis is very fast. So in that case, as I told you that this is 1.7 times sweeter than that of sucrose. So whenever you make lemon tea, do not put more sugar. Automatically the sweetness will be more. Okay, now, what are the questions you can expect from sucrose? They can ask you what is invert sugar or what is inversion of sugar. Inversion, you'll say that phenomenon is called inversion. And what is the invert sugar? So you'll say that the sucrose is dextrorotatory. On hydrolysis, it gives a mixture of equal amount of glucose and fructose. The optical rotation of fructose is more than that of glucose. And in that case, the optical rotation of the solution changes from dextro to levo. And the mixture which is there in the solution is called invert sugar. And phenomenon is known as inversion of sugar. Second question they can ask you that why sucrose is a non-reducing sugar. You can simply write that sucrose in aqueous solution, sucrose does not produce free aldehyde group, as because they do not have any hemiacetal group and cannot reduce tolerance reagent or Fehling solution. They may ask you to write the structure of fructose, or you can you can say what is being obtained on hydrolysis of sucrose. Then you have to write, because you are a chemistry student, you cannot simply write glucose and fructose. You have to write sucrose on hydrolysis gives a equimolar mixture of alpha D plus glucose and beta D minus fructose. Okay. Or if they ask you the structure of this sucrose, then you'll write that the C1 of alpha D plus glucose joins with the C2 of beta D beta D minus fructose. So this is the story of sucrose. Maltose. This formula is also same. C12 H22 O. Maltose is obtained from not from, by. By the complete hydrolysis. No, I'll not write complete. By the hydrolysis of starch. Okay? By an enzyme maltase. See, this I'm writing extra. So this is C6H10O5. This is starch. Right? This starch, when you do the hydrolysis, in presence of an enzyme called diastase. All right. Oh, I don't write this one. Maltase. Then you get here. And C12H22. This is called maltose. Maltose is composed of alpha D plus glucose units, comma, where C1 of 1 glucose unit is joined with C4 of another glucose unit through alpha glycosidic. If you don't write alpha, also no problem. I'll show you why equal to alpha. This I have given for your entrance. Alpha glycosidic link. Okay, so I'll draw it now. I'll do it like this. See, this is 1, 2, 3, 4, 5, 6. See what is going to happen now? This will go, this will be linked to this. So it is 1, 2, 3, 4. See, this is C1, C4, 5, 6. So you'll get now here. Okay. Now, why do I call it alpha glycosidic linkage? Because this ethyl linkage is below the ring. Okay. Because of this. So I can write it like this. Alpha glycosidic. This is maltose. সবকিছু কইলা তুমি তো একটা না কই যে গাবরের কমপ্লেইন করব তো বেশি বেশি করে করো
ওরা বলছে আমি কথা বলি
তুমি কইলি ওই যে এরকম কালকে তো তাই কেন ট্রাউজার ওইটার মধ্যে কামড়াই ধরছে
আমি কি বলবো সে আমি জানি ওরাও শুনে না কেন ওদের নিজের কাছে কথা নেই আমরা বাইরে গেলেও করে
I'll take only 5 minutes, huh? I know you have a class. Right here. Maltose is a colorless water soluble crystalline solid. It is less sweeter than sucrose. Now look at it is a reducing sugar because it has an a hemi-acetal group which opens up in which opens up to produce free aldehydic group in aqueous solution. In your book, they have not given, but you should know. Because many of you are going to try next year NEET exam. See here. I will again draw the structure of molecules. See it nicely, huh? See, this is the semi-acetal. So this will open up. Okay? To give you silicone. See, free LD hydric. ये जो. So this reacts with tolerance reagent. Tolerance. Then what we'll get now here? Silver. Here. So all these things you should know. So after finishing, then